Hello and welcome again. Today we look at another question from an IB past paper multiple choice. And here it says, which species contain a coordinate covalent bond? So you have two terms coming up in that question. Coordinate and covalent. So first of all, you need to recall what is a covalent bond. It's where you have atoms sharing electrons. But what is a coordinate covalent bond? And you need to remember that in a coordinate covalent bond, like in CO for instance, which is triple bonded to oxygen. Here is the Lewis structure for carbon monoxide, CO. Notice the two dots here, and these two dots represent the four valence electrons of carbon. And then these two valence electrons engage with this electron pair from oxygen to form a double bond. And then oxygen has one lone pair here. Where is oxygen's other lone pair? And that other lone pair of oxygen, that missing lone pair, its fifth and sixth electrons, both engage in making this covalent bond. Both electrons come from oxygen. And this is the nature of a coordinate covalent bond. It's where one of the two atoms in a covalent bond gives both electrons in the bond. So it's represented with an arrow going this way, which symbolizes that oxygen brings both electrons to this coordinate covalent bond. And what we need to do to solve the question now is to examine these two other structures and to see if they contain any coordinate covalent bonds. And looking at HCHO, we can draw its Lewis structure like this. And here we can see that we don't have any situation where one atom is giving both electrons in the covalent bond. So there are no coordinate covalent bonds here. So it leaves us with the last one. But even before going to the last one, just by differentiating between these two, we would have arrived at the answer to the question. Because we know that the answer cannot include one. It must include two. And two is not included by itself. Two is included with three. So immediately we know that the answer is 3. But of course it's useful to confirm this. And if we look at the structure of H3O positive, the hydronium ion, we would see that it is made up of oxygen and hydrogen with one covalent bond here, and another covalent bond over on this side, and then two lone pairs. So this is your tetrahedral electron domain geometry of the water molecule. And then to form H3O positive from H2O, a hydrogen ion with no electrons approaches this lone pair of electrons. Then this forms a covalent bond, a coordinate covalent bond, of course, because both electrons in the bond come from this oxygen atom. So that confirms for us that the answer to this question is 2 and 3. C.